So the data that we're going to be modeling with today is actually a built-in data set. And I should say that, since I'm going to be using ggplot, and I might use dplyr here. Let me zoom in. And I might use dplyr here. I've got library ggplot and library dplyr called as well. And the data I'm going to be using is the Texas housing data set that is provided, I believe, with ggplot. Let's see here. I've got a list of all of the data sets that are built in, and yep, so under ggplot package, ggplot2, it lists Texas housing data set, which is described as housing sales in Texas. So if we run this, and I just call Texas housing in there. It's basically, the records include the city, the year, the month that a sale took place, the number of sales, the volume, which I have pulled up on the right here what that is. The volume is the total value of sales, the median sales price, listings, total active listings, and then inventory, which is actually the amount of time that it takes to sell, like it would take to sell all of the current listings for that specific time. And you can see here that there's an extra column that's not listed in the info, and that's because I wanted to add a column for date. So that was just done here. I did Texas housing date column and then added an object as.date, so it's similar to as.dataframe or something like that. So I'm declaring what type of value it's going to be, and then I'm using that paste function again to paste in to that column the Texas housing year, then the month, and then I'm just making it the first of the month, and then they're going to be separated by a dash. So I've already run this before, but then we'll just run it again. So now we can do Texas housing date column, and so all I'm doing here is just combining the year and the month to get like a unique date, because that will come in handy later. Okay, but back up to our original data set. You can see that there's many data points for each city, and there's quite a few cities in this data set. So to make it easier to look at how the variables impact different cities, it's going to be different for different cities. I decided to start by just subsetting out one city. So I just picked Abilene here, which was the first city that was listed because they're listed in alphabetical order. So I just did a subset of Abilene housing is what I called it, and I'm just using square bracket subsetting to get all of the columns, all of the variables, each row that has the name Abilene for the city. So the best way to figure out what you want to model is to start by kind of visualizing your data. And we've already learned about ggplot in the last class, so I'm going to use ggplot to do that. So the first plot that I have here is calling ggplot and just using the Abilene housing subset that I made as the data, and the aesthetic mappings are going to be year on the x-axis and median on the y-axis, and it's going to be a scatter plot, so we're going to use the geom_point object. So let's just run that, and you can see that we've mapped median by year. So this will be median sales price, and remember it was stored by month, so there should be 12 points for each year. Some of them might be pretty much on top of each other, but it'll go 12, 12, 12, all the way up until 2015. And it seems that the price is increasing with time, with each year. So let's do let's also take a look at the same kind of plot, but do it by month rather than year, because median prices should also go up, you would think, during the summer months or something like that. So we can run that. And yes, they're kind of all over the place. Maybe in general, the summer months here in the middle are a little bit higher, but remember all of these points are for each given year. It's broken down by month, but there's also a year associated with each of those months. So those are kind of spread out all over the place too. So you would imagine that these higher points are associated with the later years, the more recent years, because we saw that median home prices were going up with year. So because these variables are kind of hard to parse on their own with month and year, that is why I made the date variable as well. So we should probably plot by date. So again, same thing, but this time I'm using that new date column that I made that groups in the month and year together. And it's still by median home price on the y-axis. Oops. So let's just run that. And now we're starting to see more of a pattern here. So the points for each month are distributed between the years. We could probably make these tick marks a little bit better here, but they're going every 5 years for just the median home prices in Abilene for those listings. And you can see the general trend. It's starting to become very clear that there's an upward trend from 2000 to 2015. So when you see something like this, when you see a positive slope forming like this, then we have an idea that there's some sort of positive correlation between these two variables. And we can also plot it as a line too to make it even clearer. So I've got the same plot here, but instead of geom point, instead of a scatter plot, I'm going to do geom line. And so that just connects the points into a line. And so you can see that fluctuation within the year. It usually is down at the beginning of the year because it's like the first of the month, or sorry, first month would be in January, so it's in the winter, climbs up a little bit in the summer, goes back down, and there's some fluctuation within any given year for those dates, but in general, the trend is upward. So that makes sense to see. And as I mentioned, we're starting to see that there's some sort of positive correlation going on here, but we can actually check that correlation using the core function in R, COR. So I'll just search that over here quick so we can take a look at it. And so correlation is going to take, or core is basically going to take the two things that you want to compare, so X and Y. And so I'm going to give it the Abilene housing subset date, and I have to convert it to as numeric because core takes numeric values to compare, or numeric variables to compare. And I'm going to compare it to the median, and we're going to get the return down here when I run it of what their correlation value is. So in this case, it's saying that they're highly positively correlated because it's a correlation of 0.9. And if you remember from stats, the most positive correlation would be 1, 0 would be no correlation, and then you can also have a negative correlation. So you might see a value of negative 0.9, and that would mean that they were strongly negatively correlated. So instead of that upward slope that we saw here, we would see it going the opposite way. The slope would be going the opposite way if they were negatively correlated. So we're starting to see a trend here that we could perhaps model. But before we fit a linear model to the Abilene housing, I'm just going to do a plot. If you remember in the Texas housing data set, there were a bunch of different cities. So I'm basically going to do the same plot that I just did for Abilene, but I'm going to do it for all of the cities that are in the Texas housing data set. And because that's the last cities, I have turned the legend off. So I just added a theme object with legend position equals none, just to kind of visualize that there's also going to be variation within the cities. So most of them are having that positive trend. Each one of them just has a different color because I added an aesthetic for color equals city. Most of them are having a positive trend, but there's some with a lot of variation, and some that have less of a slope, and some that have more of a slope. So some are more affected by date than other. I can also visualize individual cities. So this is the same thing where I'm using the whole Texas housing data set, color by city, but I also added a facet wrap here, which you remember breaks it into those little windows. So I'm going to get a little window for each city in there because it did it by city. And I've turned the legend off again. So I'll run that. Might take a second here because there's a lot of cities. There they are. So here it's just charting that trend of median versus date for all of the different cities that are in that data set. So we'll get back to that in a bit. But let's just focus on doing our linear model for the Abilene housing first, and then we can fit it to other cities as well. So in order to do a linear model, you just use the function called LM. So I'll just search that in the help, which it's just the function for fitting a linear model. It takes the formula. The formula argument is the argument that you have to give it. And so this is going to be basically your x by y, or whatever variable that you want to plot against the other. And you can put multiple variables in there. You can also optionally pass through a data frame giving it the variables that you want to include in the model fit. And you can also optionally give it a vector or a subset that's specifying the observations to be used in the fitting process. And more on that later. But what we're going to do is just a basic linear model of the Abilene housing median, price, and then the Abilene housing date. So this is going to be a linear model predicting the fit that we saw up here with our line, just to remind you. It's going to be a linear model predicting that fit. So we'll run that, and I'm assigning it to the variable M, which just stands for model. It's kind of convention, like assigning a data frame to DF. So it ran, M just showed up in my environment. Just go ahead and take a look at M and summary of M. So that summary of the model I just ran is going to give me my coefficients. So some of the important things to look at here is the intercept, the slope of the line that's fit with the linear model is very significant. Here's your p-values over here, and the different levels of significance are recorded with the significant codes underneath the output there. So that's very significant. And then the predictive variable that we're using, the date. So this is the variable that we're modeling median against or plotting median against, is also very significant. And another important thing to look at is your R-squared value as well. So this is fairly high, it's 0.82. So this is basically communicating the amount of variation in median that is captured by the predictive variable, which is date. So it's capturing a good amount of that variation in median. So we have some pretty high confidence in this variable being a good predictor of median. So these are just some of the more important things that I look for in these model outputs. You guys took the statistics class more recently than I did, so you probably had specific software that you would run these models with that had their own way of doing the output. So I'm just sort of running through what it looks like in R, and we'll get more practice with it in a minute. But I just want to plot this predictive line because it does exist. You can see it has a slope here where it's that it's predicting for the relationship between median and date. So I'm going to go ahead and do ggplot of the Abilene housing data with date and median as my aesthetic mappings, and this is going to be a geom line. And I'm going to plot, so this is going to look like the same graph that's over here, right? But I'm also going to plot another geom line, and I'm going to use this predict function on the y-axis, or the y-axis to plot that model that I just did that I stored in the variable m. And so I will just show predict really quick here. If you need to search it in the help, just take a look at what it does. So it takes an object, which is usually the output of a fit, output of a linear model in this case. So it's going to take all of the information in this output, the intercept, and the stuff I just showed you over here, and it's going to predict the line that would be the predicted fit between the two variables. And then I'm also going to make it a different color from the rest of from the actual line, so we can just see the difference. And so there's our predictive line. This is just a straight linear model that's just predicting the slope of the line, and it's not really capturing some of that variation between months, but we can try to do that. Try to do that over here. You can use different types of lines for your predicted fit. So I'm going to do another linear model and assign it to the output m, where I take the same formula of plotting the housing median by the housing date in Abilene, but I'm going to use the sign function here. So this is just going to make the variable that I give it, it's going to try to fit it with a sign-like shape. And if you don't remember what that looks like, I've just gone into Wolfram Alpha here and searched sign of x. So this is what I'm applying to that variable, and it's going to try and fit it with this sort of curvy line. And so I've given it the variable Abilene housing month, because as we saw, there's some variation within the month here. So you can add additional variables on the right side of this formula. You can put as many as you want in there to be used in the predictive fit. So hopefully this will produce a line that will account for some of that variation with the month variable. So we'll run that, and we'll take a look at the summary here. And it outputs a very similar thing, but this time we've got an additional variable of sign of housing month here. And it doesn't appear to be that significant, right? So it's not really capturing, that sign value isn't really capturing that month, but we can plot it anyway and see what it looks like. And also the R-squared value didn't change much either, so it's not really adding much to this model. But we can go ahead and plot it. So here I'm just doing the exact same thing with the geom line with the aesthetic of the y-axis having the predictive fit. So we'll run that. Okay, and so it's trying to fit that sign-like shape to the months, but it's not really capturing that variation too much. But the point is you can plot different line equations to try and get a better fit, and we'll see some more of that here in the next line. So now I want to get back to looking at all of the housing data. So I've got the Texas housing median here is still going to be the variable that we're going to try and predict. Other variables against. So here I'm just running my linear model again, but this time on the median sales price for all the Texas housing data set. And the formula is we're going to use we're going to have the predictive variables, or the variables we're trying to predict by, for median housing sale price on the right here. And as I said, we can do different types of lines. So for the housing date, I'm actually going to do a polyline, so it's going to allow for some curve. It's a polynomial, and it's going to be to the second degree. So you can do this to however many degrees you want. It just depends on how well it actually fits. And then I'm also adding in the city as well to see how that factors in as well. Because remember, there's many different cities, like when we did that faceted window. Let me just run that quick again. Where we had all the cities, and you can see they kind of have a similar trend going up. So now we're going to try to predict those fits for the cities, the different cities, like we did for Abilene. And so I've got the city variable in there as a predictive variable. And then I still have sign of Texas housing by month, even though that wasn't super important in there. So let's just take a look at how that pans out here. And we'll look at the summary. Running that. So this summary is going to return the results for all of these cities. And many of them are showing very strong predictive results for those variables, just like we saw with Abilene, but some of them stand out. There's the city McAllen there. Port Arthur is kind of not showing much significance. There's probably something going on in Port Arthur, as well as Texarkana. So we're starting to see that we may need to allow for some variation based on the city itself, because these cities are in different locations and there could be different things going on with their median housing prices, with their median sales prices. Just to take a look again at the facets of these cities, we can take a look at some of those ones that are showing that they don't have a very good predictive fit. So I'll just run that again. And there it is. Zoom in. And so there's a Texarkana, which kind of doesn't have much of an upward trend, so it's kind of flat. And there's Port Arthur is kind of doing something similar, and so is McAllen. So that may be why they're not really showing up as significantly predicted by the slope of that fitted line. They're not showing the same trends as Abilene is. So we're starting to see that we're going to have to account for city within our model, because they might each have a different fit. And so since we're suspecting that it's not capturing that variation of city, let's just take a look at our R squared. It's not terrible down here, but let's see if we can factor in city and get it a little bit better. So the way that we would do that, like remember our equation y equals mx plus b, we can actually factor in city not only as an addition in this variable, an additional predictive variable, but we can also factor it into the slope of the line essentially. So we're going to multiply it by this polyline, by this predictive variable of date. So we can actually do times Texas housing city and see if we can get a better fitting model with the city variable being factored into that predictive line. Running that, and then I'm going to check the summary, and the R squared is showing up here, and it is actually better, so it's now at 0.9. So factoring in the city variable into that slope of the polyline of the housing date did in fact give the model higher predictive power for the median sales price of the Texas housing data set. We can also look at an ANOVA output with just using the function ANOVA and running it on that model that I just did. And so the ANOVA function is going to output the analysis of variance tables with the data on the response variables and how predictive that they are. And so we can see that the variables we're including in the model, in this case, are very predictive. They've got pretty high p-values here, including the polynomial line multiplied by the city, which is the last one here. So it's looking like from this variable, for this response variable, we're going to have a pretty good predictive fit if we plot this for each of our cities. So that's what I'm going to do next. I'm just going to create a subset here. I'm going to subset out just the information that I want for Texas housing. So I'm just going to select out using dplyr. You could do this with something else, but I'm just going to select out the date, city, and month, and just get a subset called new data. So we'll do that, running that, and I'll take a look at new data here. Okay, so we just have the date and the city for each month, 1 through 12. And it's starting with Abilene here because it's the first city in the data set, but there's 8,592 more rows, so all the cities are in there. So this is going to allow us to plot that predictive line with some variation within the month for each of these cities. So this is going to allow us to fit the model that we did up here into a plot and plot it against what we had over here to plot it with the actual cases or the actual lines that we see for each of the cities and see how good of a predictive fit we created with our model. So that's the last thing I'm going to do here. I'm just going to do ggplot with the Texas housing data set. I am mapping on the x-axis the date and on the y-axis the median again. And I'm going to do a facet wrap by city because we basically want this exact graph over here, but with the predictive fit on top of it. So we do the geom line color equals city, so that's going to add the lines we have here of different colors for date by median. But then I'm going to also add another geom line for our predicted fit using the predict function. So this is going to be the Y aesthetic. Oops, sorry, just moved over there. Let me just get in there. Oop. Sorry, I zoomed in too far. Too far. So we're going to use the predict function in the Y aesthetic to graph that model, that fitted line with that new data subset, because remember it said it can take a subset of the data to work with in the linear model to fit to it. And then I just have theme legend position equals none. So I will just run that. And it took a minute to run, so I paused it while it was running. But let's take a look at the output, zoom in on that. And so now we have the median price. Let's see, yes, it was the median sales price on the y-axis and the date on the x-axis for all of the different cities, plotted in different colors. But then we also have our predicted model fit line on all of these, and it's a pretty good fit for most of them. The line's in black. It sort of gets weird for some of these cities that, for whatever reason, didn't have values before 2010, so it just sort of, you know, assumes the slope there, so that's not the best fit, but for most of them, it fits pretty well, that polyline shape. So that's just sort of my example of fitting linear models, exploring your data, looking at what variables are going to be most significant and trying to fit a model based on that. You can, of course, run the ANOVAs of different fit, like nested ANOVAs, different fits. You could do a polynomial fit to the third degree or something like that, and to see if it's more significant. But it just sort of takes some data exploration and messing around with this formula to sort of figure out your linear models.